Hi everybody. So today we are going to talk about the seaborn and why we need a seaborn and what are the different types of graphs and charts we are going to work today with the seaborn. So today we will we'll do some hands-on exercise with the seaborn plots like histogram, line plot, object area, and dots and all. And quickly, this is a part one tutorial. I had already shared the GitHub repository on my GitHub link, and I'll also I'll share my screen and I'll start the hands-on with the Jupyter notebook. So let me share my screen. So this is my Jupyter notebook, Jupyter lab. Now let me go and open the. Let me give this as a name, demo C1 tutorial. So this is part one. So I'm just giving it name one, but the same one has already been done. I have already created the code. So this is the exact code, Seaborn visualization tutorial part one IPM and YV. So this is already done. So today we will go through a few of the Seaborn exercises. We'll do some exercises the Seaborn and we'll understand how the Seaborn works and Seaborn dot plots and all those things are there. So we'll do this statistical visualization with the Seaborn and we'll understand how it works. So mostly it's a part of your data visualization. So what will the first thing we'll do is that we'll import the libraries. I have already written all the code, so it's all there in the uh, in the Visual Studio Code. It's already there. So what I'll do is that first I'll import few libraries. Let me go ahead and import the libraries now. Yeah, so these are the libraries you have to import. There are multiple functions that there. Like say, for example, I'll explain those functions, why I'm using those particular functions, regression, all those things. I'll explain you. So let me quickly go ahead and run our first uh, plot. So first I'm doing is that I'm trying to create a jitter plot and a cat uh, cat plot. So this jitter plot, what generally does is that, let me just first run this one. Okay, so this jitter plot, what exactly it does is that it's kind of a gives you the kind of a jittered um, uh, jitter. What it does is that it kind of gives you the now you can say that why we are using a jitter plot, why not we are using a scatter plot. So jitter plot, what is that is that jitter plot, it tries to represent the data points in the form of a single dot. So these are the data points you have, all the single dots like first, second, third. These are nothing but these are all your data points. In a similar way to scatter plot, what is done is that scatter plot shows you the categorical value. That's a major difference. The jitter plot helps you visualize the relationship between a measurement variable and a categorical variables. That's the reason. So now you might say when to use the jitter plot, when to use the scatter plot. So I would suggest to scatter plot is a better one showing the relationship between the two variables, and that's the important factor. So and jitter plot is better to show the distribution of the data when I'm trying to use a random x-axis to disperse the data points and all. So that's the reason. So scatter plot generally it tries to give you the relationship between the two variables. It tries to show you the outlier, but however, jitter plots show you the data points only. So that's a jitter pop, I can say. No, it's a jitter plot, which are lollipop chart and all those things are there. You can already do those things. Sometimes you can do a jitter plot with a bubble plot and all. That is also possible. So you can do those things and connect with that. So this is how the jitter plot works. Now let me quickly create a cat plot. So this is what a cat plot looks like. Now, why I'm using a cat plot? Now, cat plot, what it generally does is that cat plot gives you the kind of it gives you the it provides the access to the several access level functions. That shows the relationship between a numerical and a more categorical variable. So these are the numerical characteristics. Again, this shows the relationship. And cat plot also should use the outliers. I can also do some other cat plots. I can run some other, I can define a cat plot methods and all those things. The cat plot, the syntax of the cat plot method is that you define the x-axis, y-axis, and x and y are the parameters, and then you have the data, and then you define the variable data frame name with the u and all. So, and yeah. So let me do some more hands-on over here. Let me write a simple code, yeah. This is not, I'm writing it for the first time. Let me see how does it looks like. I'm loading a dataset called tips, which I already did here sometimes later, but still I'm doing it here once again. So these are tips data set I have. Now I have defined in my head with the example. Now what I do is that I can want to kind of show the, I want to kind of show a line of code. I will try to understand how to generate a simple cat plot by passing x and y and u parameter to the method. Now I want to do that. So what I'll do is that I'll simply import Seaborn as SNS. I'll simply import it, and then I also try to import the matplotlib. So I've already loaded the data set. So let me just copy it and just try to load it once again and see how does it work. It's not required though, but yeah. So let me just simply give the cat plot. I guess it should work. Now to make this work, I need to type this plot dot show. Otherwise, it won't show. Okay, it's there, right? It'll take some time to load. Yeah, so this is what it does. Now I have another example. Now in another example, we like to understand how to modify the size of the plot by using the height and the aspect parameter. So we'll pass a value to this parameter and observe the changes in the size of the in the size of the plot. So I have the same data over here. Let me copy this. Let me paste this, and my x data equal to tips x equal to, now in order to let it be the, let y tip u u equal to time. Let me define the height and all those things. Let me run this one. Let me see if it works. Yes. So this has been defined. Yeah. So now I have another example. In this example, I would like to, what I like to do is I will try to understand how the usage of the row and the column parameters, row and the column parameters take the categorical variable from the data frame, and I would like to plot them on the facet. So we will try to use a tip data set, and it has a 4 categorical value variables like the sex, day, date and time, day, time, and smoker. So we are making use of all these 4 variables in the following plot. So again, I'll try to copy this. I paste it here. My x become day, y equal to tip is fine, q equal to time, that is also fine. Now, I don't want to hide an aspect. What I want to do is that I want to define my call. Call equal to smoker. Sorry, it would be row equal to, no, row becomes x. Okay. So let me run this one. All right. So this is how it generally works. All right. I have few other examples, but I would like to kind of, I would say there's one more example I like to show. This one is the kind of, I want to kind of, there are many parameters, the seaborn.cat plot method. So there is a very useful parameter. The value is passed to this parameter. Then I would like to determine the nature of the plot drawn. It can take different values such as trips on all those things, value, violin, and all those things. I can do it. Okay. So it's a swarm plot which I'm trying to generate now. Guys, I'm not writing any hash over here because I'm just explaining those things. I believe you'll be able to follow. Now let me change the hue as max, and column is time, and let me create a swan. Let me get a swan plot now. Yeah, so this is what I'm trying to create here. I hope this makes sense to you guys. So let me jump into the next line of code which I wrote written over here in my Visual Studio Code. Now the legend will automatically place outside the plot. So let me do that. Let me create the, yeah. So I want the legend. So refer to this code, guys. This is the first one which I was writing. This is my data set. My data set is called Titanic data set. You will get the Titanic data set link. If you need the link of this data set, do comment and I'll be able to share that. And this is the data we have. And now coming to this is a separate data set, guys. This one is another one. Yeah. So this is what I'm doing here. I'm creating the kind of your automatically. I'm trying to place the label, the legend automatically here. So now what I do is that I would try to kind of additionally keyword argument needs to be passed to the underlying Seaborn functions. So for that, I'll try to kind of create this and I'll run this. See, this what it does is that it kind of creates the argument which gets passed to the underlying Seaborn function. So this is a cat plot, this is the function, and it gets passed to this function. I want to assign a variable to column or row will automatically create subplots. And I need to also control the figure size with the height and aspect. So I did the same thing here. I have done the height and aspect. I have done the same thing. So I'm doing that same thing here once again. See, I'm trying to calculate the facet, defining my height and uh, uh, aspect. But it's a kind of a bar. I can also create a swamp. Here I have defined the swamp. Here I have defined kind of the swamp. So I'm defining here as a bar. See, it's a bar. So the bar is coming up. So you can define those things as per your requirement. Now I'm trying to create a violin plot. I need to create a violin plot. I'll explain why we need a violin plot, guys. So this is a code which I used is there. Just go through the code once. Try to see what is the code is all about. So when I'm creating a violin plot, it's a very simple syntax I am trying to create. This is the violin plot which gets generated. No, violin plot is a kind of a hybrid of a box plot and a kernel density plot. It shows the peak in the data. It's showing the peak of the data. See, these are the peak of the data. Okay, so this is what the violin plot it shows. Now let me quickly go ahead and So this is the lower points. These are the higher points. So more data points distribution, the more data points distribution are there here. Interquartile range can be defined. You can define your interquartile range. You can define your kernel density estimation boundary as well with the violin plot. So there are two types of violin plot. We have a univariate analysis, and we can create a univariate violin plot, and then the bivariate analysis. So let me quickly create a univariate plot for you. Already the libraries are there. So let me create a randomly. I'm doing it for the random, and I'm randomly generating a data. Just 100 data points I'm trying to generate, and then I'll try to define. This is my data, by the way. So let me define it. Now, I want to show the median as well. So I am defining median as a true. If you do not want the median, but it's recommended that you show the median to see how your data plot has been defined. Now I have to set the data plots. This is the X label. Now I'm defining the Y label. I have to define the plot title as well. This is a univariate variant plot which I'm creating here, and I need to show the plot. So this is a very minor comment. You may not write this. You may write this. It's plot dot show function. Have to generate the random data np dot random dot seed. This will generate the data. I'm defining my data. I have to import numpy as np as well. I think it should work now. There are some syntactical mistake here, guys. Um, yes, so now it is done. So you can see the um, uh, uh, univariate violin plot. This is the univariate violin plot. So there was some syntactical mistake, guys. So which, yeah. So similar way, I would show you how to create the bivariate and all in my next tutorial video. And so violin plot, this is how it has to be created. So I hope you understand the upper adjacent value is there, there's the density plot, wide frequency, median is there, interquartile range, and lower adjacent value. These are the few things which are required. And how you interpret it's a violin plot, what generally does is summarize the data set using six measures, the box plot, which is used to show the minimum, the first quartile, the median, and the third quartile. So this is how it generally does. In my previous videos, I have shown you the median interquartile range, how I'm running the interquartile range and all in the player data set. Over there, I have done that. So you can just go to my previous video. You can understand why I'm doing those things. Yeah. Now this one, when I'm writing, so this one will create your first class, second class, third class, and main women, children. This will give the categorical values, and yeah, this will give all the values of your bar. Now I have to load another data called penguins data set. Let me load that data, penguins data. And then I'll try to run a pair plot with that penguins data set. And my U will be species. This is my pair plot with the penguins data set. Okay. Now, why we need a pair plot? So pair plot, when I do a pair plot, so pair plot would be able to kind of define the level of interface for how the pair plot will be multiple pairwise bivariate distribution will be able to show the pair plot. So pair plot, what it does is that it shows the multiple pairwise bivariate distribution. So pair, that's the pair plot. This is a distribution within these all the pairs. This show the bivariate distributions. That's the reason the function of pair plots are used. Guys, when I say U, let me explain the code, guys. Some people are asking me what is the example of U. So when I say U, H-U-E, what is that? It's a variable in the data to map the plot aspect to the different colors. Data is your data frame for each column in a variable. And yeah, so this is the U is all about. Let me do a pair plot with the tips data set, guys. I have the tips data set previously. I have loaded it. So let me do the tips data set. Let me create a pair plot with this. So I have this tips equal to SNS dot load and the tips. So let me define this as the DF. These are not required. Now what I can do is that I want to pair plot with the use sets. Okay, so let me do this pair plot. All right, so let me write the code syntax for that. Let me see if it works or not. Okay, so Seaborn, I need to change here. Make it as an SNS. You can also import Seaborn if you want, and then it will also work in that way. But I haven't imported it. That's the reason. Yeah. So this is how the pair plot for the team dataset looks like. Yeah. So this is a common syntax for the pair plot. Yeah. Now I have another little data set as a kind of health X. So let me create the object area with this data set. So what object area plot does is that it defines the plot area of that entire object. It defines the field area plot, including a changing color, size, log axis, and mode in your graph. A number of the objects is equal to the number of the plotted area, and that is to modify the properties of the area. So plot area, what does is that it defines the 2D. It's completely a 2D chart, guys. It's not 3D. Contains the data markers, grid lines, and data labels, trend lines, and optional chart item, which is placed in the area chart. Yeah. So let me play around with this. Now I'm trying to add few color properties. See, I've added some color properties here. What I'm next going to do is that I'm trying to kind of map only the edge color. So I'll quickly go and run this. All right, so you see the edge color got changed. Now, what I'm going to do is that the mark has drawn in the polygon. So I'm going to kind of draw a kind of a shaded region by setting the edge white 0. The next thing is that I'm trying to kind of create this spending and area, USD area. I'll take those things and I'll define those things. Spending USD is my x-axis and your y is the y-axis. So based on that, I will defining Germany, France, I'll define those countries. I'll look into the spending aspect now. Here and the spending in USD for all the countries. Yeah. The USA is this country, so all the countries have this spending pattern. Now again, I'll try to get the Dow Jones data set and try to create a kind of a line plot. Line plots are very simple plot. It shows you all the lines, the movement across all. These are very good for the time series forecasting, guys. If you're doing a time series forecasting, I'll try to upload few more videos on the time series forecasting. And now this data set, now in x-axis I'm defining price and y-axis I'm defining date. This is very simple. Line plots are very simple. There's no much to discuss. So just try to understand why I'm using a line plot. So line plot, it defines the graphical display of the data along a kind of number of the lines, x-axis and y-axis. So these are the dots. We try to kind of join those dots and create a line plot. You can similarly do this with the matplot as well. So yeah, but I'm doing SNS as of now. You can define your styling, you can change the styling, you can create a matplot. You can do the iris dataset as well. You can load the iris dataset and you can do that. So let me do that with the iris dataset. I'm not writing any comments over here because I'm explaining all those things. Now I'm simply I'll do a kind of draw a line plot. I have to define my x. Let's explain with a simple length. And y equal to, maybe I can define y as my simple width. What else? And my data is data. That's it, guys. The next command should be plot.show. See, I created the line plot with that. You can play with a lot of things. You can define that. You can define the bins and line plot and all. You can play around with multiple things. And I can download the tips data set. I can create a line plot with that. Define my style and all those things. So let me do that for you with my tips data set. This becomes very bit easy and all. X would be my tips. That X would be let it be total bill. Y might be the size. Let U be the sex. That's it. And let me define my style as well. See, we got the line plot for your active data set. That's all, guys. Let me quickly come into my Visual Code. This one, I guess I had already done this. Now I'm creating a dot plot. Dot plot is nothing but it gives you the kind of the dots of the data points and nothing else. So again, I'm using a tip data set here. So it gives the dots. See, I'm kind of giving you the dots. Now what I want to do is that while dots is a better choice, now I'm kind of create a dense scatter plot for this. But sometimes dot is very simple. I don't know how it's behaving in a particular point of time. So what I need is that I can create a dense scatter plot for these dots. It's kind of giving the scatter plots. Now I want to kind of create the jitters for this. I can also reduce the overplotting and create a jitter for this. It will reduce the overplotting and looks bit diverse. It look bit professional. It kind of give you the labels and all those things. Now, if I have to combine my completely range to show the error bars and all, there might be some error bars. So yeah, this will show the errors. See, these are the all error bars. And all. I hope you understand what the error bars are. So error bars, it will show you the like error bar, like the how what are the different errors we have, and how to remove the error bars and all. So error bars will be able to kind of in a graph. What error bars they do is that they graphical representation of the variability of the data, which are trying to indicate the error of uncertain unreported measurements. So those are the error bars we have. What generally they do is that kind of they show you the precise measurement, how far the reported value is true error free or which might be. The error bars are kind of they kind of indicate the errors, nothing else. Okay, as simple as that. Now I'll come into the histogram. It's very simple, histogram. Like I have been working on histogram for a long time. I have created all my videos. I have created histograms, and also I'll simply download the penguin dataset and I'll try to write the histogram dataset. So I'll create a histogram. So this is the histogram I have created. Now, why I am creating a histogram? What is the histogram plot is useful for? So histogram, what it does, it shows the frequency distribution. It shows the number of the observation within each given interval. That's a basic thing, histogram. All right. Okay, so this is histogram is done. Now let me see if I can do something else here. Now in histogram, X is a kind of array or sequence of array. Bins is like the sequence of string optional parameter, and the density is the optional parameter that contains the Boolean values and all. Range is the range of the parameter, upper and lower range of the bins. His type is the type of the histogram, bar, stack, steps, all those things are there. Like I'll show you all the different types of histogram in another video. I'll try to create the tutorials for that. Like you have the alliance, you have the wet, you have the bottom, R weight, color, label, and log. So just keep a note of all those things. You can manage around all those things and all. I'm not going into much deep with that. It's very simple. So I'll keep it in that way so that you can understand. Once you understand the depth of the histogram, why we are using it and how you're defining the histogram for the particular categorical values and frequency distribution, then we'll be able to jump into the advanced. Now I'm trying to kind of estimate a univariate distribution, So I'm trying to create a univariate distribution. Now let me plot this. This is my univariate distribution of the histogram. Now I can play around with this histogram a lot of time. I can do adjusting the. I'm trying to adjust the granularity by setting the total number. Now that I can do here, I'll simply define my bins and number 20, and I can do that. Now I want to specify the width of the bins. Just now I set up the width. So yeah, so this is the width. I can set up the width of my bins. Now I want to kind of normalize the counts to show the proportions. So I will just simply copy this and speed this. I just very, very simple one-liner code, and then you can show the proportions of that. Okay. Now what you can do is that I want to kind of additionally variable to define the groups and all. I'll explain the code, guys. Additional variables are there. Now I have to define the groups. And now default behavior is to normalize the across all the groups. There are some additional variables are there. So I want to kind of normalize them. Okay. So, some additional variables are there. So I have to kind of normalize them. So I'll drop it here. Now normalize each distribution. I have to normalize each distribution. So this has to be normalized. See, this has got normalized. Each distribution has to be very in a normalized way. Otherwise, you will not be able to kind of work with your algorithms and all. They'll not perform properly. There might be some problem with overfitting, underfitting. Might be normal. So normalization is very important. And then you have to visualize all those things. normalizing in terms of the sex and the column, common nouns. Now, when the distribution overlaps, what you can do here, when the distribution overlaps, you simply, it becomes very easier to discern their shapes with an area mark. So I'm trying to show an area mark where the normalization has been overlapped. See, the normalization of overlaps, I'm trying to show an area curve where the normalization is overlapped between male and female. The next is I'm trying to kind of add the stack move to represent the part where the relationship exists. This is a stack bar I'm trying to add to represent the part where the relationship exists. So this is what I'm trying to do is that I'm trying to define the histogram of the stack relationship between male and female to exist. The last but not the least is the Seaborn lines. This is simple line plots which I'm trying to create. This will show you the lines of the data points. See, this will show the lines of the data points. Now I want to compare to the line which is marked, which offer the like settable properties and all, but it can have the better performance when dragging a large number of large number of lines. What you can do is that you can set your properties. You can make sure that they do not kind of scatter around with each other, and they can format each other in such a way that each has own all the years and all can be properly skewed, and you can see how they are performing, how they are skewed or not about all the particular years. So this is how it looks like. So that's all, guys. That's all the end of this demo program, Seaborn tutorial part 1. There are a few more things which I'm going to do in my next video. So keep in, follow me, like and subscribe. If you really like this video, do comment. If you need any help, I'll be there. So yeah, so that's all, guys. I'd like to stop this video and yeah, thanks all.